Hello everyone and welcome to another episode of the World Cement Podcast with me, your host David Bizley, Senior Editor of World Cement. In today's episode we dive into Heidelberg Materials ReConcrete program. We'll explore the challenge that ReConcrete is aiming to solve, the scale of emissions reductions it promises, and the origins of the whole approach. Beyond the technology, we discuss product performance, regulatory pathways, market adoption, and the team's vision for scaling ReConcrete over the coming years. And to help me through all of that is today's guest, Nicolas Pato, Team Leader for Industrial Tests and Implementation at Heidelberg Materials Global Research, Development and Innovation Division.
Optimizing your cement plant. Empowering your team. SEM AI presents the expansion of its AI and machine learning offerings by providing a new process optimization solution, SEM AI Process Optimizer. Combining the power of AI and machine learning with cement-specific expertise, SEM AI Process Optimizer enables a step change in production volumes, energy efficiency, and consistent quality output. Predictive maintenance and real-time optimization are now in your hands. Find out more at semai.com.
So, Nicolas, welcome to the World Cement Podcast. Thank you for joining us. We've got lots to get into today.
Thanks, David.
So, to kick things off then, tell us about ReConcrete. What is it and what problem is it trying to solve?
ReConcrete is a breakthrough technology developed by Heidelberg Materials in our global R&D center in Germany that tackles two major environmental challenges in the concrete industry: construction waste and CO2 emissions. It's built on two core innovations: selective separation and enforced carbonation. First, the selective separation allows us to recover high-quality recycled aggregates and sand and recycled cement paste, this is RCP, on the other side, turning waste concrete into well-valorized raw materials. Afterwards, the enforced carbonations take the RCP and reacts this new material with CO2, for example, from raw flue gases from our cement plant. By this, we create a new reactive material which is called carbonated RCP, CRCP, that can replace traditional clinker in cement production. So, what's the problem the technology is solving? ReConcrete not only reduces emissions, virgin material extraction and landfill use all at once, but also closes the material loop, making concrete truly a circular material. Selective separation is demonstrated and operational at commercial scale since 2024 in a concrete recycling facility close to Katowice in Poland. On the other side, enforced carbonation was commissioned this year in an industrial scale pilot, which is integrated into our cement plant in Górażdże, also in Poland. So this is the very rare example of rapid innovation in a traditionally slow-moving industry.
Okay, excellent. Now, we mentioned emission savings in your response. What kinds of emission savings does this technology promise?
That's really the heart of ReConcrete. ReConcrete offers a powerful way to cut emissions in the cement and concrete industry, which is one of the largest industrial CO2 sources of CO2 worldwide. Clinker production, this is the most intensive step in cement production and manufacturing, emits an average of 750 to 850 kilograms of CO2 per ton of clinker. So with ReConcrete, we tackle this challenge in two ways. First, by actively capturing and mineralizing CO2 during the enforced carbonation of recycled concrete paste. In that process, it's about 150 kilos of CO2 per ton of RCP. Second, by replacing clinker with the carbonated RCP, so the CRCP in cement production, which avoids another 850 kilograms of CO2. So combined, that's a potential reduction of 900 to 1,000 kilograms of CO2 per ton of RCP.
Well, okay.
Through both capture and avoidance. The enforced carbonation step locks CO2 into stable minerals like calcite using exhaust gases from the cement kiln. So you are just not avoiding emissions, you are permanently storing them. And the potential, of course, this is huge because each waste concrete can be processed by ReConcrete.
Right, okay. So what was the genesis moment, if you will? What was the driver that helped you realize that this particular approach would be a viable path for decarbonizing concrete?
The genesis moment for the ReConcrete approach emerged from a critical realization within the cement industry and concrete business. Conventional recycling methods were not fully utilizing the environmental potential of demolished concrete, especially the cement-based component, so the finer fraction of after recycling of concrete. While only coarse aggregates were being reused in low-grade applications, the finer fraction, this means a mix of sand and hydrated cement paste, which is rich in calcium, was largely discarded despite its potential to bind CO2 and act as a reactive material.
Right.
This insight, combined with the growing urgency to decarbonize cement production, led our researchers at the Heidelberg Materials in our research center to explore how CO2 mineralization could be industrialized. The turning point was recognizing that recycled concrete paste could be transformed into a valuable supplementary cementitious material, so an HCM, through enforced carbonation, simultaneously sequestering CO2 and replacing clinker.
Right.
Which is the most carbon-intensive component of the cement. So the common touch point of circular economy principles, carbon capture, and utilization potential, and material performance made it clear that the approach could offer a viable, scalable path towards low-carbon concrete, especially as a traditional SCMs like fly ash and slag become less available. This realization catalyzed the development of ReConcrete technology and the integration into industrial trials and EU-funded innovation projects with the aim to prove that the concept can be accelerated and implemented quickly.
Okay, excellent. So you mentioned earlier that in July last year, you commissioned a recycling plant for selective separation in Katowice, Poland. What was special about this facility and what role did it play in the broader ReConcrete approach?
Yeah, the selective separation recycling plant that we are operating since last year in Katowice was a significant milestone in the ReConcrete approach. What made this facility special is the industrial scale deployment of an advanced mechanical separation technologies, first of the kind worldwide in the application for concrete recycling to recover high quality recycled aggregate sand and most innovative material, the RCP, so the recycled cement paste, from construction and demolition waste. Unlike conventional recycling plants that produce low-grade material for road base or backfill, the Katowice facility was designed to fully valorize all concrete components, including the fine fraction, separated in recycled sand and RCP. The RCP is then transferred to the enforced carbonation reactor, where it's transformed into a reactive supplementary cementitious material, enabling CO2 sequestration and clinker substitution in cement production. So the plant in Katowice plays a central role in the ReConcrete strategy, serving as the upstream source of recycling materials for carbonation and cement blending. And at the end, it demonstrated the feasibility of closing the material loop in concrete production and sets the stage for broader industrial adoption across Europe and beyond.
Okay, excellent. And then a year later, July this year, again also in Poland, you commissioned the enforced carbonation pilot at Górażdże, where the RCP attained at Katowice is processed. So tell us a bit about how the carbonation process actually works. What are the steps involved?
Yeah, sure. This is the next step after the recycling. The enforced carbonation pilot commission in Górażdże this year in Poland is another key component of ReConcrete approach and is designed to transform recycling the cement paste, so RCP, producing our selective separation facility in Katowice, into a carbonated supplementary cementitious material, which is the CRCP. At Górażdże, the process is all about turning waste into value while locking away the CO2. We start by taking the recycled paste from Katowice and adjusting the moisture content, which is the optimum for a carbonation process. Then it enters into a rotary reactor that operates under ambient conditions and uses the raw exhaust gases from one of our cement kilns without any previous treatment of the CO2 flue gases. Inside the reactor, a mechanical process boosts the surface areas of the particles, making the carbonation reaction fast and efficient. The CO2 binds the calcium-rich phases in the paste, forming stable minerals like calcite and a pozzolanic alumina silica gel. These products are not just inert, they are highly reactive and perfect for making low-carbon composite cement. So overall, the process is very simple. You feed raw flue gases and RCP into the reactor and extract the carbonated gas and carbonated RCP from it. So instead of sending concrete waste to landfill and letting the CO2 escape to the atmosphere, we capture the gases and embed it permanently into a material that strengthens the next generation of concrete. It's a circular solution that combines recycling with carbon capture in one integrated process.
Excellent. And bearing in mind that Górażdże is a pilot plant, what kind of production levels are you looking at? And do you have plans to scale output at this facility?
The enforced carbonation plant at Górażdże is an industrial demonstrator designed to validate the technology under real operating conditions. It runs in continuous mode and processes around about 1.5 tons of recycled concrete paste an hour, so 1.5 tons of RCP per hour. Since this is a demonstration facility rather than a commercial installation, we don't plan to scale it up at this location. However, scaling is much more part of our roadmap, of course, and we are already securing EU funding to build a unit roughly 10 times bigger, and the construction will begin in Belgium next year, also close to one of our cement plants. Beyond that, we are exploring additional opportunities both inside and outside Europe, and the outlook is very promising.
Okay, excellent. So some updates in the near future, hopefully, then.
Yeah, indeed.
So regarding the end product itself then, how does the performance of concrete and materials produced via the ReConcrete process compare with the traditional products? Are there any differences, in fact?
Concrete made with ReConcrete materials perform just as well as traditional concrete, and it comes in some cases with even better properties. One of the standout characteristics is the early strength development. Thanks to the high reactivity of the carbonated recycled paste, the strength builds up very quickly in the first few days, which is a big advantage for fast-track projects,
Sure.
For example. Overall, the compressive strength at 28 days is fully comparable to conventional mixes, and the durability meets all the standard requirements. Workability is similar as well, with one of the slight increase in the water demand, but this is easily managed with standard admixtures and chemicals. So you get the same reliability and performance, plus a significantly lower carbon footprint.
Okay, excellent. And how do you plan on dealing with things like regulatory issues? For example, how mineralized CO2 is treated by carbon accounting frameworks, or how are building standards recognizing ReConcrete products as acceptable?
Regulation is key, of course, for ReConcrete success. The upcoming ETS revision already considers CO2 mineralization to be equivalent to carbon storage. On the materials side, standards are evolving. The EN 197 Part 6 now allows recycled concrete fines in cement, and we are pushing for broader acceptance and introduction of carbonated cement paste through performance-based standards. Based on convincing quality of the recycled aggregate that we produce in our selective separation plant in Katowice, a new concrete standard allows us to 100% use of such aggregates in structural concrete, and this has just been published in Poland. So things are indeed moving in the right direction. We are deeply involved in European projects and standardization bodies to make sure that ReConcrete is not only technically proven but fully recognized in the market. Perhaps one of the main obstacles are the waste regulation and the established non-circular recycling practices, that this is both leading to missing the potential that the waste concrete has.
Okay. And I think you mentioned the market there as well. Now, one of the challenges that sort of greener products often face, despite recent changes in the right direction, is that of market demand. How are you working to ensure there's a strong uptake for ReConcrete products once they're ready for commercial deployment?
Of course, market acceptance is critical, and we are tackling this challenge on several fronts. First, we've proven that ReConcrete delivers the same performance as traditional concrete, which builds confidence among engineers and contractors, for example. And second, we are working closely with the regulators and standardization bodies, so these products are fully recognized in codes and procurement frameworks. And finally, we are engaging the market through pilot projects and partnerships to showcase real-world applications, so not only research. The combination of technical validation, regulatory alignment, and strong sustainability credentials position ReConcrete as a natural choice for low-carbon construction. We have recently communicated the launch of SEM Loop XL. This is the European-funded project in Belgium, where we partner with ETEX, a leader in the production of fiber cement products. This is a very good example. They will supply us with RCP from fibers. We will apply ReConcrete, our technology, in our cement plant in Lixe, and deliver back to ETEX a high-quality carbonated RCP for the production of low-carbon fiber cement. This is an excellent example of commercial deployment of ReConcrete in collaboration with our customers directly.
Okay, fantastic. Looking ahead then, what milestones should we be expecting from the ReConcrete program over the next couple of years? Any highlights you could pinpoint for us?
I would say that the next phase is all about the validation, scaling, and being ready for market introduction. First, we complete the full operational validation of Górażdże pilot, fine-tuning the process parameter to assure that the constant quality from diverse demolition waste streams. And then comes the expansion phase, commercial scale units inside and outside Europe, as mentioned, including the major plant in Lixe in Belgium that be about 10 times larger than our current pilot in Poland. Alongside that, we will launch pilot construction projects and training programs to build confidence in the market. Finally, we will complete the life cycle and economic assessment to quantify the CO2 savings and the cost effectiveness, supporting the policy advocacy and green procurement. By 2027, the goal is clear: move from pilot to commercial deployment and position ReConcrete as a scalable solution for decarbonizing concrete and driving circular construction worldwide.
Okay, excellent. Lots to look forward to then over the next few years. Nicolas, thank you so much for your time today and for guiding us through the ReConcrete program.
Yeah, thanks, David. It was a pleasure talking to you.
And as always, a big thank you to everyone in the World Cement podcast audience. If you have enjoyed this episode, please leave a rating or review, and make sure to subscribe if you still haven't already done so. And as we approach nearly the end of the first year of the World Cement podcast, we've built up quite a back catalogue of episodes worth checking out. So why not take some time to have a look at a few of those as well. Thanks again, everyone, and goodbye for now.
Optimizing your cement plant. Empowering your team. SEM AI presents the expansion of its AI and machine learning offerings by providing a new process optimization solution, SEM AI Process Optimizer. Combining the power of AI and machine learning with cement-specific expertise, SEM AI Process Optimizer enables a step change in production volumes, energy efficiency, and consistent quality output. Predictive maintenance and real-time optimization are now in your hands. Find out more at semai.com.